Grade 11 pre-cal, lesson 45, multiplying and dividing radical expressions. So multiplying and dividing is generally pretty easy. The key here is they have to have the same index. So they both have to be square roots or cube roots or quad roots. Other than that, you can just go ahead and multiply it. So let's just go through examples here. So we have -3 root of 2x times 4 root of 6. So all you do is you take the numbers that are out front, so the -3 and the 4, multiply those together. You take the radicands, everything underneath the root symbol, the 2x and the 6, and just multiply those together. So we end up with -12 root of 12x. Then you have to simplify. Well, 12x can break down into 4 and 3. We can take the square root of 4, which is 2, bring it out, so -12 times 2, root of 3x. So we end up with -24 root of 3x. So it's really quite simple. The key is they have to have the same index. They have to either be square roots, cube roots, quad roots, or anything like that. Okay, so this next one, we can do distributive properties. So we have 7 root of 3 multiplied by everything within the brackets. So we do the first one, 7 root of 3 times 5 root of 5, right there. And then we have 7 root of 3 times -6 root of 3 right here. Okay, do the same thing. The 7 and the 5, the 3 and the 5. The -7 and the 6, and the 3 and the 3. And we just keep going down, so we end up with 35 root of 15 minus 42 root of 9. 15 can't break down, but that 9 can break down, right? Root of 9 is 3, so -42 times 3. So we end up with 35 root of 15 minus 126. Straightforward. Now we have two binomials. Again, you can do FOIL. So 8 root of 2 times 9 root of 5, 8 root of 2 times 6 root of 10, -5 times 9 root of 5, and -5 times 6 root of 10. And then just go through and do everything, right? The 8 and the 9 is the 72. The 2 and the 5 is the 10, right? So we end up with 72 root of 10. The 8 and the 6 is 48. The 2 and the 10 is 20. The -5 and the 9 is -45 root of 5, and -30 root of 10. And then see what you can reduce. The 10 can't reduce, but the 20 can reduce down to a 4 and a 5. So the root of 20 breaks down to 4 root of 5. The root of 4 is 2. 4 times 48 is 96 root of 5. So then we end up with this line right here. And then, can you collect like radicals? We did that lesson already. Yes, we can. We can collect the 10s and we can collect the 5s. So 42 root of 10 plus 51 root of 5. And the order doesn't matter. If you had 51 root of 5 plus 42 root of 10, that's also acceptable. Okay, go to the second page and we'll talk about dividing. So dividing, the key concept here again is they have to have the same index. So they have to both be square roots, or both be cube roots, or both be quad roots, right? And then we just go ahead and do everything. So we got a 4 and a 2 and a 6 and a 3. Well, it's really relatively easy. 4 divided by 2 is 2. It's cube root. Root of 6 divided by root of 3 is root of 2. Okay? If you don't like them when they're separate like this, you can put them all together. So we end up with the square root of 24x squared over 3x. Well, can we reduce that? Yeah. 24 divided by 3 is 8. X squared divided by x. Now you remember, same base, you're dividing, so you subtract the exponent. So there's a 1 above that x there, right? So we end up with root of 8x. Can we break this down? Yeah, the 8 can break down to 4 and 2. The square root of 4 is 2, goes outside the symbol. So we have 2 root of 2x. Now something we're going to come across this, and I think this is coming up in one of the other lessons, is whenever you have a fraction, you never leave your fraction without reducing it. Well, in math, you never leave a radical on the bottom. So right now we have 3 root of 2 on the bottom. So what we want to do is we want to get rid of that root of 2. Well, to get rid of the root of 2, we just times it by root of 2. And if we multiply the denominator by root of 2, we have to multiply the numerator by root of 2. So what we do is we multiply them both by root of 2. So the bottom, look at this, we get 3 root of 4. And the top, we end up with 4 root of 5n times 2. So at the top, we end with 4 root of 10n, and the bottom, we end up with, now, this root of 4 is 2. 3 times 2 is 6. Yeah, great. Now, if you notice, there is no radical on the bottom anymore. So we just keep doing the math here. So there's our 4 root of 10n of 6. What can you take out of both? That 4 can break down to a 2 and a 2, and the 6 can break down to a 2 and a 3. Basically, what you do is you can divide the 2 out of both the numerator and the denominator. You're reducing your radical. So we end up with 2 root of 10n divided by 3. Now, that's coming up, I think, in the next lesson in 46. We're going to talk about rationalizing denominators. This is just a little pre-lesson into that one.